Oh, wait. Okay, so I did post an announcement about this. At 2 o'clock today, the homework will be available, the next homework. Tomorrow at midnight, I chose midnight. I'm not sure why, honestly, but the quiz will be available then. The second quiz, that is. Okay. And I was going to say, so those are going to be available. I know Tuesday we don't have class. I know we don't meet on Tuesdays anyway, but Tuesday is a wellness day, I think, if I remember correctly. I do expect to hold office hours on Tuesday, even though there's no classes. But as far as I know, I should be able to hold office hours then. I think I'm allowed to. I mean, if anything changes, I'll let you know. So we have that. Let me see. Office hours. That. I'm trying to think. I know the test is coming up. Let's see. Okay, so I will let you know what the first test will be on. When it's posted and everything, I will let you know. Okay. The dates are on the syllabus. If I remember correctly, I think the first test is supposed to be on the 22nd, but again, it's take home, so you'll have a few days to complete it. So, I haven't made it up yet. Okay. Are there any questions at all? Okay. That said, let me start lecturing then. Okay, I did email the notes to everyone, and I think I emailed the worksheet as well. So what we're doing, remember, is we're looking at factor by grouping. What I figured we'd do today is I do an example, let everyone try one, then I'll go through it, and then a worksheet I think we would all work on together. I mean, I would let you try it out for a bit, then we would go through it together. I just wanted to point this out. I think this came up, I don't remember if it was this class or the second class. It might have been this one. The first step, factoring out the GCF, I mean, I guess technically you can skip that, but if you're factoring completely, which means you're factoring until you can't factor anymore, then you want to factor out the GCF. But if you're just doing factor by grouping, step one, you can really skip if you need to. It's just something I wanted to point out. Okay. All right, but the other steps are all the same, okay, for factor by grouping. So what I want to do is I want to do this example together. Then the next one I would have everyone try. Okay. I know these examples are kind of long. The next factoring technique actually builds on factor by grouping, just letting everyone know. And I'm hoping if not today, then we'll start that on Monday. Okay. So again, we have 4 terms here, right? And notice these are not like terms, right? They're monomials in the variable x, but because the exponents of x are different, you cannot combine these. You can't combine them. So what we can do though is factor. Okay. So I'm going to find the GCF first though. That's what I like to do. Notice there's a coefficient of 1 here, right? In the last term here. So because of that, we know that the only factor of 1 is 1 itself. So the greatest common factor among the coefficients here, okay, is going to be 1, because the only factor of 1 is 1 itself. Can everyone? Okay. If for some reason you can't see the notes or you can't, again, hear me, just, let me know. Okay, but I think everything's good though. Okay. So the greatest common factor among the coefficients is 1. But notice the smallest exponent of x here is 2. So going back to that GCF, right? It's a monomial of the form b times x to the m, right? We get b has to be 1. That was the greatest common factor among the coefficients. M is 2, right? So we get the GCF is x squared. 1 times x squared, which is just x squared. So we're going to factor that out. Factor it out. Remember, what does that mean? You put it in front, right? And you divide by it. And remember, when you divide by a sum or a difference, you have to divide into each term. You divide into each term. I've seen students in the past, they would maybe divide x squared into one, but not in the others. You always divide into each term. Okay? All right. So once we do that, you're basically subtracting exponents of x. So we have x squared times 12x to the fifth, 4x to the fifth over x squared, that's 4x cubed. 3x to the fourth over x squared, that's 3x squared. X squared over x squared is 1. Okay, good. Okay, so that's what we get. Now, are we done? No, now we want to factor this 4-term polynomial. Okay, and here again, we're going to use factor by grouping. So what do? We form two groups of 2. Two groups of 2. Okay. Okay, so for the first group, right? Let's factor this. And again, by factoring each group, we basically mean you're going to factor out the GCF from each group. So you find the GCF and factor it out is what I mean. So from here, we have 3 is the smallest exponent of x, right? So m equals 3 in the GCF. Also 4 and 12, right? You know, those are the coefficients. Since 4 is a factor of 12, 4 is the greatest common factor among 4 and 12, among the coefficients. I mean, I did write out the factors here, but hopefully you can still see that 4 is the greatest common factor among the coefficients. So B is 4. We got M is 3. So the GCF for this group is 4x cubed. And now we're going to factor that out. And that's what we're doing down here. 4x cubed, we put it in front, and we divide to see what's left over. And when you divide into each term, like so. Here, what do we get? 12 over 4 is 3. X to the fifth over x cubed is x squared. 4x cubes cancel, you get 1. Okay, yeah?
Can you just explain what happened to the 3x squared?
To where? You mean here?
Yeah.
We're not there yet, though.
Okay.
What we did remember was we formed the two groups with parentheses in factor by grouping.
Mm-hmm.
And from each group, we have to find the GCF and factor it out. And we're working on the first group.
Oh, okay. Sorry.
Okay?
Yeah.
No, that's okay. Awesome. Very good question. Any other questions? I know this is not easy, so if you have a question, don't be afraid to ask me. I know this is not easy. Okay. So we have the first one. We have 4x cubed times 3x squared plus 1. Okay, now we have to handle this. But hopefully you can see that the second group, the GCF is going to be 1 of the second group. I mean, really, it's because, well, for one reason, it's what you end up with when we factored out the GCF from the first group, right? From the first group. So I had to go back and forth like this. The 4x cubed was the GCF. We factor it out, right? And we're left with 4x cubed times 3x squared plus 1. So this here has a GCF of 1. Okay, that's probably confusing. But another reason is we have a 1 here as a non-zero constant term. That forces the GCF to be 1. That's another reason. Mostly because, again, if you have a non-zero constant term, actually, let me point it over here. If you have a non-zero constant term of 1, right, the smallest exponent of x is 0. The only factor of 1 is 1 itself. So the greatest common factor among the coefficients and, and the constant term has to be 1. So, yeah. Question?
So I just have a question. It's more technical than anything, but like when we went back to the beginning of the problem, when we factored out the x squared,
Yeah.
and we left, and so like we have to put the +1 at the end there for this to work? Because
Yeah,
like
because
I'm assuming like you can't like factor it if you have x squared on the outside, you need to have a +1 there for it to like work.
well, yeah, because when you divide by x squared, you have a 1 left over.
Okay, yeah, that's what I thought. But I got confused at first because I just factored out the x squared and I was left with 12x to the fifth, 4x to the third, 3x squared, and I thought we were gonna like multiply, like do the AC method where we have 12 times 3. But
Oh, no, not yet. No.
so we have to put that 1 there when that stuff happens.
You have to, yeah, because we divided, there was an x squared here.
All right, thank you.
Okay, you're welcome. That's okay. Good question. But I mean, I hope it's making sense here why 3x squared plus 1 has a GCF of 1. And that's actually good because here, as you can see, in factor by grouping, remember, in parentheses, you want the same thing to occur, right? So here we have 3x squared plus 1 in parentheses. The same thing is occurring in parentheses. So what we do next, is we have to factor out 3x squared plus 1, which is in parentheses. That comes out. And that's what I'm doing here. So we factored each individual group. You want the same thing to occur in parentheses. Okay? And now whatever that common thing is, 3x squared plus 1, we factor it out. And we get this, right? We put it in front. We have to divide because we have to see what's left over. Let me put parentheses in there. What I have is correct, but just to make it a little bit easier, let me add parentheses. That might help a bit. As you can see, like so. Okay, so we put it out in front. We divide because we're seeing what's left over. And when you divide into each term. So now these are going to cancel. This cancels with this. And we're left with, we have the 3x squared plus 1 in front. And we have 4x cubed that's left over. And we have a 1 over here. Because again, we took out the 3x squared plus 1, meaning we divided by it, and we get 1 left over. So all together, right, we took out x squared first, we factored this, we end up here. Okay. I know that was, probably confusing, but are there any questions on that? Let me just get the recording.